Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about trigonometric ratios for special angles. And before we get on with that, let me just introduce to you guys two different diagrams here. So these diagrams here will be useful in filling up the blanks on this table here. So let's consider having a triangle where there is 45 degrees on this side, another 45 degrees here, and this is 90 degrees. And since the angles here are the same, the length of this side will be similar. And if you consider the length here to be 1 unit, and this is also 1 unit, then you can easily find the length of this one. So this is the hypotenuse, using the Pythagoras theorem, where you can take the square root of this one. So 1 must be squared first, plus this one also, the length here must also be squared, and then you will get the answer will be set 2, so as given by this diagram. Now in this diagram, you have 60 degrees on this side and 30 degrees and 90 degrees. So the total here will be 180 degrees. So that's something that you should remember when you talk about the triangle. The sum of the angles will be 180 degrees. And if this is 1 unit and this is 3 units, you can find the length of hypotenuse. So the length can be found using the Pythagoras theorem. So you take the square root of this one being squared first, plus this one also have to be squared. So next it will be 1 plus 3, and this becomes set 4. This is equals to 2. So with that in place, we are now ready to fill up the blanks on this table, and we're going to start off with angle 30 degrees. So this is the angle of interest, so this is 30 degrees, and based on this we know that sine of 30 degrees is according to what you have seen on this slide. This is the relationship between acute angle and the lengths of two of its sides. So this is the trigonometric ratios, and you can see the ideas here and incorporate that on this table in order to find the answers. So sine of 30 degrees, that will be 1 over 2. Okay, 1 over 2. Opposite over hypotenuse. Cosine of theta is already given. That will be adjacent over hypotenuse. Tangent of theta is opposite over adjacent. So that will be 1 over 3. Next, cosecant of theta is already given. Secant of theta is just 1 over cos theta, and 1 over cos theta is this one. So based on that, I'm going to write down, okay, cos of theta is sec 3 over 2, and this is equal to the final answer being 2 over sec 3. Okay, next let's look at the next triangle, which is the next angle, which is 45 degrees. Maybe we can consider this one. So sine of 45 degrees is 1 over sec 2, 1 over sec 2. Tangent of 45 degrees, 1 over 1. Oops, sorry. So 1 over 1, which is just 1. Secant of theta is 1 over cos theta. So 1 over cos theta, the answer here will be flipped. So that will be sec2 over 1, which is just sec2. And that's it. We are done with angle 45 degrees. Next, we are going to continue with angle of 60 degrees. So for 60 degrees, this is the angle of interest. Sine of 60 degrees is sec3 over 2. So sec3 over 2. Tangent of 60 degrees, so tangent is sec3 over 1. And then secant of theta, secant of 60 degrees. So secant is 1 over cos. So this is cos of 60 degrees. So 1 over this value. Therefore, the value here will be flipped. So it will be 2 over 1, which is just 2. Alright, so the next one, we will be looking at angle of 0 degrees and 90 degrees. But for this one, I'm going to introduce what is called the unit circle. So I'm going to introduce to you guys the idea of unit circle. Let's say this is the y-axis, and this is the x-axis, y-axis. So the unit circle is basically a circle with radius 1. Okay, I hope this looks alright. So basically the radius here is 1. So from the point of origin to this one, the radius is 1. Similarly, this is radius 1. Okay, so all these, this is a circle of radius 1. Okay, you can imagine that being drawn like this. So now on this circle, it is also possible for me to draw a right angle triangle. So let's say that I have a right angle triangle. Okay, so this is my right angle triangle. And clearly, based on this construction of triangle, I can say that the length of this one will be 1, because this is the radius. So this is 1, the length of it. And at this point here, the coordinate will be unknown, but you can call it A and B, coordinate A and B. So so at this point, this will become B, and at this point, if you drop it down here, this will become A. So based on this, I hope you can see that the length here will be B, and the length of this one will definitely be A, because the point of origin from 0 to this A, the length here will also be A. Okay, so now we have a triangle where the length is defined as this one is A, this is B, and this is 1. So if I have an angle, say this is my angle, so let's say this is my angle, and my angle theta. So based on this simple diagram, I can say that sine of theta will be b over 1. So b is the y coordinate. So b is actually my y coordinate. So b over 1. Cosine of theta will be a over 1. But a is also the x coordinate. It's not just the length, but it's also the coordinate. And tangent of theta will be b over a. So b here over a. Okay. So now, if you talk about 0 degrees, the angle is 0 degrees. You can imagine, I hope you can imagine that it is like having this line here. It is like having this line going downwards in this direction until it touches the initial side here, and so the degree becomes 0. Do you get what I mean? Okay, I'm going to just like enlarge the triangle. So this one here is the initial side. Okay, so this is the line here, and this is another line. An angle is measured. Angle corresponds to the intersection of these two lines. So this is theta. Now what if this line, the terminal line over here, is moved downwards so that it actually on the same overlapping the initial line here, so that the degree now is 0. So just going to erase this. So I hope you get the idea. We have the line, which is this one here, and it is moved downwards, so that now the angle here, theta here, becomes 0. So imagine this line, it's moving downwards and touches the line here, which is the initial line, the initial side, and so theta becomes 0. And since this is along the unit circle, when it stops here, the coordinate of A and B, so this is the coordinate of A and B, which is this coordinate you're talking about. The coordinate A of B now can be determined easily, because it would just be 1 and 0. Your x here will be at point 1, and your y is at point 0. Why is it 1? Because again, you're talking about the unit circle, where the radius is 1. And because of that, I can determine what is sine of 0. Sine of theta when theta is 0 is just b over 1. B is the y coordinate. So b is 0. So 0 over 1 is going to be 0. Now, for cosine of theta when theta is 0 is a over 1. And my a is 1. So 1 over 1, the answer is 1. So for tangent of theta is b over a. So b is 0, 0 over 1, the answer will be 0. Now for secant of theta is just 1 over cos theta. Cos theta is 1, so 1 over 1 is just equal to 1. Okay, now for cosecant of theta, so let's look at cosecant of theta. Cosecant of theta is 1 over sine of theta. Sine of theta is 0, so 1 over 0 becomes undefined. Similarly, for cotangent of theta, the result here is also undefined. Now, how about angle 90 degrees? So now let's consider the angle of 90 degrees. So following the similar idea, let's say that originally this is what you have. I'm going to just draw a simple diagram here. So this is the initial site, and this is the terminal site, where originally you have this point here of coordinate A and B. So this is your theta. So let's say that this terminal site here is moved along the circle, okay, along this unit circle. So it's going in this direction, and then it stops here, so that the angle that it makes with respect to the initial side here will be 90 degrees. So the angle will be 90 degrees. So now the point A and B here is moved towards this point. So A and B here will be at this point, and this value can be determined easily because like I said earlier, this is inside a unit circle. So this length here can be determined as 0 for A and 1 for B. Okay, so again you can imagine that this line here is moved along this circle, and it stops here, so that it makes a 90 degrees with respect to the initial side. And so the point here can be determined as, this is the coordinate for x and y, and because the radius is 1, you can determine the coordinate to be 0 and 1. X is 0 and y is 1. Therefore, when you want to find what is sine 90 degrees, sine 90 degrees is b over 1. So 0 here correspond to A, and y is b, and 1 is b. So sine of theta is b over 1, b is 1, so 1 over 1 is 1. Now tangent theta is b over A, cosine theta is already given, so tangent theta is b over A. So b is 1 over 0, 1 over 0, it becomes undefined. So 1 over 0, so this is actually undefined. Okay. Next, secant of theta is 1 over cos theta. So cos theta is 0, so 1 over 0. And again, this is also undefined. Alright, I think that's all for now. I will see you again in the next video with ideas, with other basic ideas related to trigonometry. Well, thank you very much for watching. Have a nice day.